Welcome to MyProjectBazaar.com. Let me discuss about the process QoS-aware node selection algorithm for routing protocols in VANETs. Let me discuss about the abstract of the project. In this project, QoS-aware node selection algorithm for routing protocol is proposed. Our algorithm aims to select the next hop vehicle to communicate. Most VANET applications are built upon the data push communication model, where information is disseminated to a set of vehicles. In vehicular ad hoc networks, vehicles transmit traffic and safety related information is disseminated to a set of vehicles. In networks, transmit traffic and safety related information, accident warnings and accident reports, etc., which assist drivers in making proper decisions to avoid vehicle collisions and congestion. Vehicular ad hoc networks are created by applying the principles of mobile ad hoc networks, the spontaneous creation of wireless network for data exchange to the domain of vehicles. They are a key component of intelligent transportation systems. VANETs support a wide range of applications, from simple one-hop information dissemination, cooperative awareness messages, to multi-hop dissemination of messages over vast distance. Most of the concerns of interest to mobile ad hoc networks are of interest in VANETs, but the details differ. Rather than moving at random, vehicles tend to move in an organized fashion. The interactions of the roadside equipment can likewise be characterized fairly accurately. And finally, most vehicles are restricted in their range of motion, for example by being constrained to follow a paved way. In this project, the system presents QoS-aware node selection algorithm for routing protocol, a novel multi-channel TDM MAC protocol proposed specifically for a VANET scenario application in vehicular networks can have different QoS requirements. Some applications require minimum delay regardless of the throughput, while others require the opposite, and some applications may need a balance between throughput and average time delay. Moreover, QoS utilizes a transmission range based metric that can be changed as per application requirements, whether it is a high throughput or minimum end-to-end delay. Let me discuss about the flow diagram for our process. In the system model, the objective of analysis is to investigate how fast the contending nodes can acquire a time slot on channel by using the QoS-aware node selection algorithm for routing protocol. Key K denotes the number of contending nodes, each of which needs to acquire a time slot on channel. The system wants to determine the average number of nodes which acquire a time slot within n frames. The probability that a specific node acquires a time slot within n frames. Next, in the QoS algorithm, the choice between the vehicles V1 and V3 can be achieved by restricting the region from where the east vehicle selects the west vehicle. This restriction should be defined slowly based on the type of application, since some vehicular network application require minimum delay regardless of the throughput, while the other application require maximum throughput but are delay. In order to overcome this trade-off, QoS algorithm needs to allow the vehicle to select the farthest possible vehicle available in a specific area within the transmission range. The probability of estimation. So probability estimation has been all the contending nodes belong to the same set of THs with the same T0 and TA. Node W and node X in its final position. Set of THs to which the contending nodes belong does not change. Set A is not assigned when a node fails to acquire a time slot alter frames. All nodes are within the communication range of each other. At the end of each frame, all contending nodes are informed whether not their attempts to access a time slot during this frame were successful. Based on this information, each collecting node randomly chooses an available time slot from the updated A set and attempts to access this slot during frame. Finally, the performance has been analyzed. In this QoS technique, which is primarily a forwarding node selection algorithm for routing protocols in opportunities vehicular networks. QoS allows vehicles on one side of the highway to successfully select a vehicle from the opposite side, that improves the QoS metrics for the network. QoS metrics used to analyze the algorithm total communication time, throughput, and packet end-to-end time delay. Finally, QoS in vehicle networks have shown significant improvement by QoS in terms of throughput, end-to-end packet delay. Finally, they introduced FRP parameter, and it provides better performance based on the QoS requirements for VANET application. Let me discuss about the running procedure for our process. Select the main.m file in the current folder, right click the file and run for executing this process. Here, vehicular ad hoc networks are performed based on the QoS algorithm. In this algorithm, we obtain the result. This is the vehicle representation. Green color nodes represents the number of vehicles, and this black color circle indicates the communication range of the vehicles. If any one vehicles within the communication comes within the communication range, then the communication between those vehicles will be performed. This is the performance analysis graph. Here, total time communicated for performing communication process will be analyzed based on the vehicle density. By varying the vehicle density, we analyze the communication range based on the QoS algorithm. Here, the range will be varied. That means full range, 0.75% range, and 0.5% range, and 25% range. Next graph indicates the throughput. Here, the packet delivery ratio has been analyzed based on by estimating the throughput. This process performed based on the algorithm QoS algorithm. By varying the vehicle density and also by varying the ranges of the communication range, we can analyze the throughput between each vehicle. And finally, the average time delay has been estimated by varying the communication range, and also for different values of vehicle density, we analyze the time delay, that is packet delivery delay of the time based on the QoS algorithm. Thank you.